you hear me? Do you hear me? Hello, do you hear me? Hello, hello everyone. Can anyone just confirm if you hear me well? Can you write in the chat? Perfect. Yes, yes, it's okay. Perfect. Super. I'm very glad that you hear me well. So we are just about to start in 2 minutes. So feel free to just bring some uh, coffee, water, what do you have. So we will, I think, start 4 p.m. and the webinar will last around 2 hours. We will see. We never know. Probably if you follow previous Beam Corner webinars, often we maybe do it a bit longer. So hopefully we will today stick to the time, but you also will get recording after, so don't worry, you will not miss anything. We are now around 91 people. That's great. This is perfect. If I can increase my volume, let's do it like that. Do you hear me now better? If you can hear me better now? Yes, okay. This is, I'm also a beginner in this streaming world, but thank you for the feedback. I think it will be good now. So, okay, guys, it's almost 4 p.m. Central European time. So before I jump to the topic, I also want to give you some basic information about how we're going to proceed during the webinar. My name is Marcin Pszczółka, and I will be the presenter today. I will talk about closer to your little bit closer to your mouth. Okay, let's do it like that. Is it now better? Let's see. Uh, okay, if yes, then I just continue. Excellent. Oh, perfect. Yes, glad you like it. So, guys, my name is Marcin Pszczółka, and I today will talk about IFC in infrastructure. For infrastructure, so just short housekeeping for all of you. So, if you want to see the presentation in the highest quality, highest possible, just make sure that you select this option in your YouTube. So this is the thing you have to take care yourself. So this is the first thing. And the second thing, if you want to ask a question, if you want me to answer this question, please use this form. So you need to open the chat. And when you click on the chat, you will see probably the window that appeared on the top. So you have to just click on it and click ask something, and then you write the question and you send the question. Then I will get this question in kind of the lobby, and then I can come back to this question later. So I will have a control over the chat, but in terms of the questions, I will come back to the questions later, or in any time I will see that this is maybe relevant to answer. So just please uh, ask question this way. And of course, there could be some mistakes, but anyway, I would like to have it structured also to be sure that all your questions will be answered. So before we jump to the topic, let's also ask some simple question. So I have a very nice Slido for you, Slido form. So let's see where do we come from. So if you could just scan QR code um, with your phone and type your type your country. Where do you come from? Because I have noticed that in the registration form there were more than 90 countries. It's amazing. So I'm really, I would like to really see if you guys uh, are also. Yes, so Costa Rica, wow, Italy, Romania, Latvia, super, Norway, yes, Hungary, Ireland, oh my God, Germany, oh my God, Poland, Portugal, Azerbaijan, London, Washington even, Washington, US, Germany, Spain, oh my God, Kenya, Dublin, Czechia, wow, it's a lot of countries in one online room, and also people writing on the chat like Brazil, Botswana even. Yes, I have seen Botswana today. This was the last country registered today. Botswana, Brazil, California, US. Oh my God, there is a lot of people from around the globe. So I see that the topic is very important, and all these countries want to know more about it. So this is perfect that you have found this session. Korea, even Nigeria, Ethiopia, Saudi Arabia. Wow, amazing! This is amazing. So I'm really glad, guys, that you have found the time, or I don't know what time is in your place, but probably for some of you it's also challenging to wake up or go sleep quite late. So yes, this is the exactly what I wanted to show, that how many people really want to talk in the same language, and this workshop will be about this, about the IFC, the common standard that should work for all of us here gathered together. So still people sending the messages where they are come from, but I think we are okay. Let's jump to the other question. So guys, now please, what are your expectation from this webinar? So if you can now answer, it's the same Slido. If you could answer briefly what you would like to learn today. Also, this gives me information, what should I focus the most, or which topic should I elaborate most about. This is also good feedback for me, because when you have a certain knowledge about the topic, then you are not aware if this what you think it's important, and what kind of topics could be relevant for you. So I see here like IFC 4.3 for infrastructure, IFC in maintenance, more about IFC 4.3, OpenBeam in general, global overview and link on useful sources, uh, practical application, understand better IFC 4.3, knowledge, data integration, state of industry regarding IFC 4.3, as I will come back to this. Format itself, basics, great. This is going to be for sure very nice startup for you. Tools also. I will try to talk about the tools, about the mapping, more about IFC 4.3 in roads. I think in my session I will cover more of this topics. So don't be afraid to ask anytime. If you have any question, just please write using the form I presented, and then I will answer all your questions. So be sure that everything will be answered today, or if I don't have a proper answer for you, I will come back later and send the answer in by mail, or you can also type me directly, because I will give you my credentials. Okay, guys, I think we have it. So let's just go and start the webinar. just brief introduction about myself for those of you who doesn't know me. My name is Marcin Pszczółka. I'm based in Poland, but I have been living in Norway almost 9 years. So I have almost or over 10 years experience in AEC and industry. So I worked previously or worked as a road designer, railway designer, BIM manager, BIM coordinator, also a lot as a product manager in the huge company called Trimble. Now I'm also civil. I'm working as a civil design lead. So 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 in this um, in this sense, I think I have like a kind of a broad knowledge regarding the using and implementation IFC 4.3. I'm also co-founder of BIM Corner blog. So if you are familiar with our blog, I'm one of the co-writers there. So I have been kind of leading this initiative almost for 6 years together with my colleagues. In addition, I'm also representing my previous companies on a different events as an international speaker, and also I'm really like to talk about the BIM. But what I'm going to show you today, this is basically my expertise. So during the last years I focused a lot about on IFC 4.3 and BIM for infrastructure. So this is what I'm going to present today. So I hope you will enjoy this session. So this is if you also want to contact, just make sure that you write somewhere my email, and I will you can always send me a mail message. I will answer. I'm trying to answer all the questions, all the emails. Okay, so let's begin. So now we will have a bit more technicality. So before we jump to the topic IFC 4.3, we also have to understand that nowadays there is also possibility, or it was also before possibility to save your data to IFC. And this is, for example, it could be done using IFC 2x3 or IFC 4, but the issue was that there was not one classification approach, that many companies had own definitions, had own classifications, and they use it in their own projects as they want. So we couldn't have the same foundation. We couldn't uh, get kind of reach the level where all the projects could use the same terminology. So this was possible to done, and this was possible to do. And as you see, the IFC, the previous IFC or the current also IFC 2x3 was made mainly for buildings. So you can classify uh, your road using building story. So this is not consistent. It's very difficult also to understand what the author uh, was thinking and why they structured the road model or any infrastructure model this way. So it was very challenging to really follow the pattern in different projects. So, but also it could look like that we had this situation where you use the building element proxies, and this is a very bad example where you basically all classes, all geometries, all entities having the shape, having a geometry, just placed or just attached to any IFC building element. And this was very difficult because it also didn't give any value in filtering or mapping processes. So if you wanted to export your file to any receiving software, it was very, very difficult to kind of filter out only data you want to work with. So that's why I think the building element proxy is not the best idea to use. Of course, is possible, and I know that many projects using this approach because, for example, you can have a building element proxy, but also very rich attribution or very rich property sets. So it's possible, but sometimes some receiving software, some viewers, uh, like they present the data, so you miss the kind of very basic level of understanding. If so, for example, I'm a huge fan of defining objects or distributing objects, native objects, and mapping them to the different classes, because this also help us later to filter data, as I said, in different tools quite easily. So why we really need the IFC 4.3 in the industry? Because I see this as a one common language, and this is a perfect solution now for infrastructure. So as I said, we have IFC with us quite a long time, but there was never before the standard that could help us, the infrastructure engineers, to classify data in the right way. So I see this as a one common language that we can speak together and understand each other, and also our models could kind of pass our validation routines or any other requirements that we set to the project. So we need also understand that IFC could be our foundation, and IFC 4.3 could be our foundation. I know that this is us, and you will also probably learn from this webinar that we can start with that, but also on top of it, we can add much more semantics, much more logic, or any additional information. So this is very good starting point, that we have a standard that could be used across different domains in infrastructure world, and we also can communicate with the building or vertical building environment. Before it was quite limited, or as I said, it could be not easily done. Now with this classification, which is suitable for infrastructure, we are kind of opening more chances to work together in one federated environment. So also a bit about the story behind IFC. So you probably know, if you are interested in BIM, that IFC standard was quite long with us. So we have almost with us IFC almost 25 years or even more. But the IFC 4.3 with us is since 2024, uh, or it's since then it's certified, because we have to say that IFC 4.3 is certified. It means that we can rely on it. It's ISO certified, and the version of it, it's called IFC 4.3 Addendum 2. So if you will receive a file or you will send a file, make sure that the information about the format it's addendum 2, because some tools could, for example, not open your file because you don't have uh, uh, this information at the end of the IFC name. And also just want to point to one situation. As you see, infrastructure development took very much time, because it is very challenging in terms, for example, of linear placement, of georeferencing or alignment. All these terms or all these elements in infrastructure are very challenging. So that's why it took almost 10 years to develop this standard, because you can say, oh, what is the difference between 2x3 or 4? If the class is just extended classes, yes, but in IFC 4.3 you have more geometry definitions. You have also new objects, new explicit parameters that could be used to determine properly models. So that's why it took that so much time to develop the last IFC standard we have. So what we have inside our IFC 4.3, what scope we can cover with this standard. So there is a certain domains we are supporting now. So buildings were always with us in IFC world. Now we can also determine or describe a bridge. We can also describe a railway domain and also road and marine facility. So this is the five main domains, or you can call it disciplines, or um, call it as you wish, but this is the kind of the areas where we can now fit our standard and find some default definitions that could be to serve to in our modeling or our beam management. So this is the five main, but also you have to know that in addition, it could be also much more for infrastructure. And there is some definitions that are not, we cannot place them or we cannot reserve them only for one domain. And the objects, we can call them shared infrastructure elements, because imagine that when you design a road or bridge or a railway, you also need certain information or certain elements. For example, about terrain or geotechnical survey or a topological survey. All this information we can now easily define in IFC, but they are kind of describing or they are kind of creating a new group of elements. And these groups, like a more common that could be used across different domains, are geotechnical, earthworks, pavement could be also used in many different disciplines. Like pavement could be found in railway or could be found in roads, but even on the bridge you could have the pavement, or even you can have a coarse layers in the water and sewage systems in the trenches. Then we have a signs, the same issue. Signs could be also used in different domains. Signals and impact protection device. So here could be an example, like you have a bumper that could be used in railway at the end of the track, or you could have a crash cushion that could be used in railway, usually used in on the motorways, installed on the motorways or any high-speed expressways. So this is the definitions that could be found also that are suitable for infrastructure. So what others or what elements basically we are talking now about, because we have these groups. Yes, you know now more or less what we can cover, but let's see what definitions or what objects we can find there. So the first and most important objects in IFC 4.3, and this is also why the whole development took so much time, is IFC alignment. IFC alignment, if you are the engineer, infrastructure engineer, you probably know what is that. So alignment is the path of our corridor in, like simply saying, in roads or railway, but it also could be used for the bridges, or it could also be used in any scenario where we want to, for example, place some objects along the line. So alignment could be also used to define to be used to stake out the data in the field. So I was recently working in the Trimble company, as I said, and you know, Trimble is a company owning the software and hardware. So we were testing IFC receiving IFC in the Trimble Access software that is used on the construction site. So based on alignment information, we could easily stake out information. And you know probably that alignment was exchanged using LandXML format. So with IFC 4.3 now it's also possible to use this standard to this format to exchange information about that. So alignment also consists of horizontal, vertical, but also alignment count. So you can also define a count information for railway projects. And alignment is used also, as I said, for linear placement. So if you have, let's say, a sign and you want to not only place it in the global coordinates, but you also want to attach it to the network, to the link, you can also do it in IFC using alignment. So this is the first and most important object that you should be aware of. Another one that it's also connected to this object is IFC referent. An IFC referent is basically information that, for example, could be used as a position along alignment, giving us information about the stationing. So this is the object. And also there is a one rule in the validation service, I will mention about the validation service later, which says that every alignment has to provide at least one IFC referent. So that's why I'm also want to introduce you this object, because you find it in the proper export. You should find this IFC referent also in your model. So IFC referent is it's the just it's the object, as I said, describing information. And here you see the screenshot from a tool called US Beam Browser, and US Beam Browser has very nice uh, viewer for alignment layout. So if you design alignment, or if you save your alignment in IFC 4.3, then you can open it in USB in browser. And for example, if you have everything correctly attached to your alignment, all the definitions, you could get very nice dynamic view, very vertical view as you see here. So we have all this reference, as you see, every, let's say, every 10 meters. Sorry, this is maybe 50 meters. Then you have horizontal alignment, you have a count definitions, vertical, everything. So you can dynamically prepare your drawing based on the properly defined data. And you see here also the example with the signal that could be attached and also described properly in terms of the placement along the alignment. So this is also where referent could help you to store this information in some way. So this is a referent. Another important object that is also outside the scope, like not the tangible objects, which I like to describe, it's annotation. An annotation was also previously implemented in the previous standards, but now we also got these definitions to work with the survey data. So you know, in infrastructure that we have a certain objects or certain solid elements or certain let's say elements is a good word, that we not only need the shape, the shell of the objects, but we also need the line, for example, that line or the point, insertion point, and this is where annotation could help us. So this information also before were stored in different file formats. Here we can store it inside IFC and take the advantage of it in the, for example, in execution phases where you need really this information. So the example here is that you can have a string lines along alignment along the roads. You can have also the point and the line for the manhole and pipes, or you have also insertion point for the sign. So this is a typical situation where you use this properly described survey data. So this is, as you see, the objects that are not placed in any of this group I mentioned before. This is something you have to be aware of. Let's jump now to more tangible objects, as I said, like objects having the geometry, the real geometry, let's say solid or surface. So this is existing situation. So now with IFC, we are now closer to GIS world. So it means that you can convert GIS data into IFC using certain definitions. And here you see that we can describe, for example, contour lines using also annotation but different predefined type. I will explain predefined type a bit later. You have again a survey data, for example, for something what is measured, because if you create your existing situation, you can combine the kind of data you have from different sources. So survey data are one of them. You have a build elements to define your existing buildings or any other structures that you can insert to your model. And you could also describe your terrain using a geographical IFC geographical element with predefined terrain. So this is a typical objects that could be used to define your existing situation. And as you know, existing situation is very, very important in the in infrastructure projects, in especially in BIM. So with the definitions we have today, we can uh, more precisely describe it as it was before. As I said before, it was possible. Of course, we had solid representations, surfaces, but now we have more clarity, better approach, better consistency, less misunderstanding. So this is existing situation. Let's see how it looks in the roads. So roads elements also got a whole package of objects or definitions that could be used. And here you have a simple cross section that I try to describe with different definitions. So you see that we have alignment, we have earthworks fill for the subgrade layers, we have for embankments, we have a pavement, we have slopes on the right and left side, we have line marking, we also have a guardrail, we also could have a signal assembly, and this is also specific object. I just want to tell you about this one. There is no definitions about the sign. It's a signal assembly, but in description you can find that it could be used there and that. You can also use maybe your own definitions, like using the user define approach, and then define, for example, your object type. I will talk about this later. But you see, we have quite many different objects or many different classes, entities that could be used also to road description. Let's see how it looks for a railway. Railway is a similar thing. We also have much more information to describe our corridor data, because here I'm focusing on the corridor elements, not talking about the catenary, about the wires, because we could describe it also before. In this sense, like when we talk about the electrical components, assemblies, it was possible to describe it before. Maybe we have now more definitions, but in terms of the alignment, or sorry, corridor design, you see that we have much more. This is a richer, the richer basket of definitions that could be used to define our railway elements. And this is also quite positive that we can do it right now. So another domain, let's jump to now to the bridge. So here is also a snapshot of a very simple bridge, or maybe not that simple if you are a bridge engineer. So probably you will say that this is not easy to design, but as you can see, we also find definitions that almost all the objects could be easily describe easily defined with this. So this is also great that nowadays uh, bridge have own bridge has own definitions that could be used. And I will also show you another domain, the last one from this topic. And you see here, this is stormwater elements. So we can also describe underground utilities with the certain definitions, certain classifications. So this is one of the rare examples, maybe not that much used or not that much explain in different places. So as you see, we can describe the pipe, we can describe manhole, we can also describe different parts of manhole using this approach, as I said, with user defined. And then you can also describe your trench and have the survey data. As I said, for this specific domain, survey data is quite important. So this is what you can do with the classifications, with the classes, IFC classes. But let's go a bit deeper because I told you about the definitions, and as you see, all these definitions has a dot, and with capital letters we have some term. What is that? And this is called the predefined type, and this is the attribute. So now I would like to talk with you about the attributes. So what is exactly attributes? So imagine if you open your IFC, everyone can do that in Notepad or any viewer, or sorry, any text viewer, because as you know, IFC you can also open in the Notepad. And then when you open it, you will see the lines like here on the top. So for example, this one is describing that we have in row 22, we have a bridge part, and in the parentheses we have some definitions. And these definitions are called attributes. And this is another tool I'm using quite often. It's called RDF. If you are interested, I can also send you a link. This is my best tool I use for this um, kind of to see the relations, to see classifications, to see different attributes. And this is where I can also try to understand what attributes I have attached to my object. And you see that this one is, for example, a global ID. This one is a name. Here was some owner history. Here is another example that here, for example, is a composition type. We don't have a defined usage type, and predefined type is abutment. So this is what you call attributes. So all information that you find in this string in the step file, it's called the step file. When you open in Notepad, you see the step code. It's all this information are called attributes, and we can have a certain amount of them. I just listed here the attributes uh, that are uh, that are kind of representing the spatial elements, and the IFC bridge part is a spatial element. I will also cover this topic later. So this is where you basically can define different information. So if you have a good understanding of this, then you can easily determine different requirements regarding that. So you can, for example, say that this specific object should always have a long name defined this way, or they always need to put description. And this information could be also tracked very easily in any software, allowing you to open to read the IFC data. So I also recommend to go deeper in this topic and see what kind of what different objects, which what attributes they have. And this is very easy way to check. You have to open the documentation, and you just to need to go to any objects you wish, and then you find a table like this, and you will find that the 11, so from the top level you have the predefined type, but you can also see 29 hidden attributes that are describing some levels above, because in IFC we kind of inherit attributes from the top, from the root. Maybe there will be also a place to describe this in the details, but uh, just saying this in short. So you have a certain amount of attributes, and you have to know about, and that's why I recommend you to be familiar with them, because some of them could be also nice to, for example, standardize. If you're writing some documentation or you write some requirements, this could be a very nice approach, just defining this in front of any projects you participate in. And predefined type, I told you, this is what I mean. So predefined type describing or giving you extra layer of definitions to your existing class. So instead of creating huge amount of objects describing your element, it's better, or building smart, or the people committee working with it, the specialists working with standard decided that the better approach in general, it will be defining the predefined types, which are the next level of the description to your object. So you have example here that we have IFC course, which is very generic, but if we, for example, put there a predefined type pavement, that we know that this could potentially be used in roads. If we have a ballast bed, so everyone knows, or every infrastructure specialist knows, that this is the specific objects in railways. If we have the filter, it's also specific objects that it's used for the specific in specific cases. Armor in marine, for example, marine facilities. So this is, you see, we have one object, one entity, and we can give the more logical meaning using this using this special predefined type. Then what I want to say, there is a one, because all the attributes, almost, if you check, are optional, so you don't have to define all of them. I think the obligatory is for sure global ID, and maybe, I think only global ID, maybe name, maybe, don't remember. But there is also one called usage type, and this is attributes that is describing uh, spatial elements, spatial entities, and this gives you the dimensions in which you considering your elements, your models. So as you see, for example, on this snapshot here, so we have, for example, usage type which is longitudinal, and we have also lateral. I will go deeper in this specific topic later when we will talk about the spatial entities. But just remember this usage type, it's a mandatory, and I just learned this myself because I tested when I was in Trimble. I tested a lot of IFC files in validation service by building smart. So when I didn't put this usage type to my spatial elements, I always got a warning that, hey, Marcin, no, they didn't say Marcin, but hey, you don't have this information. You should always include it in your model, in your on your objects, because it's the not optional, it's obligatory. And this is what you need to understand. So in addition, you can also, let's imagine how you can divide this model. So I assume that you could, for example, use the vertical usage type. There is also definition called for this usage type called vertical. And the bridge could be also the mixture or mix of both, maybe lateral, maybe longitudinal, based on how you want to approach this topic. Then let's go to property sets because we have now attributes. You know which definitions objects we have. You know now that we objects also have attributes. And now let's see what property sets are. So I don't want to talk about the definitions, how they are linked, but I just want to tell you one thing which is maybe important to mention. So property sets are exceeding, like giving us more and more understanding of what information are attached to the or what information we want to ship with our models, with our objects. And we have, of course, in IFC 4.3 new definitions, new property sets that allowing us to describe in in detail infrastructure assets. But one thing I want to just point out, it's you can define your property sets and attach to the objects based on the predefined type. So for example, you have, here is a good example, you have a property set road guard element, but this P set could be applied only to railing, IFC railing with definition, with the property, with predefined type guardrail, or to IFC wall parapet, railing type guardrail, or wall type parapet. It means that this specific property set, it's not attached to directly to the class, but to the class with predefined type. And this mechanism, you can believe me, it's very, very difficult in terms of implementation because this is a kind of logic you have to create in your software that allows you to attach just the certain property set to the specific objects having this defined attribute. So also this is an important aspect to remember, that we have this kind of logic also. And as I said, property sets works the same as in other versions of IFC. So you have a certain amount of building smart default property sets, and of course you can extend your classes with the definitions that are more adjusted to your project or adjusted to your requirements. So this is nothing changed here, and this is still the same, still the same as it was. Okay, now let's jump to the next one. So coordinate reference system. So coordinate reference system is also something that you could probably know from different kind of file formats. But now also it was introduced in IFC4, but not fully supported. Now this coordinate reference system also allows us to locate our files more precisely in terms of the different zones and areas in the global coordinates. So this is what you can include in your file, and also based on this information, this is very nice way of validating your data. For example, I worked in with the software called Trimble Quadri. So when you inserted the file that was outside the area, you could get this notification, and it was about preventing you of doing the mistake. So this is very nice that you can exchange data, but in addition, on top of that, you can validate if it's correctly placed or not. And I know that there is a lot of problems in our industry according that, because sometimes, for example, in Norway, you have a lot of different zones. It could be NTM or it could be UTM, and sometimes there is a mismatch, and you get everything looks fine in federated model, but at the end, like one domain design in UTM, another in NTM, so there is some problems with the rotation, some movements. So this is how we can prevent it when we just store this information in IFC. And also because Quadri is more as a maybe not authoring software, but it's like kind of hybrid, let's say, that you have to import and transfer your data. But I have seen recently that some viewers also supporting these definitions, and this is one of this. Here is the box. I think this is a software called KTM from Germany. I don't know if I said it correctly. Maybe I can come back to it. But recently I tested this, and when I insert my file, I got the information, or I was asked if I were asked if I can if I rely on this reference system. They call it spatial reference system, if it's correct or not. So this is also in the viewers. You can find it as well. This logic. So this is what you need to know. Relations, also important topic, because relations, you as a IFC specialist you have to be aware that there is a certain amount of different definitions for relations, and this is also beauty of IFC, because IFC is not only the geometry, not only property sets or objects with attributes, but also there is a lot of relations which gives us another context. So here is the picture showing how the spatial breakdown structure, what relations they use. So if you have a IFC road, so of course on above that you have IFC project, IFC site, then you have a IFC road part. So IFC road with road part is connected using IFC real aggregates. This is the definitions you have to know. If you again open your viewer notepad, you will probably, when you search this term, you will find a lot of real aggregates. Maybe not a lot of, but if you have IFC building story, also between them are its IFC real aggregates. But if you have, for example, IFC course attached to IFC road part, so this one is using something called IFC rel contained in spatial structure relation. So IFC is all about different relations. So one object could use various relations type to define the specific use case. And here is the example. I just listed the most common definitions that, or the most common relations that I have found useful in infrastructure. Of course, there is much more. I didn't cover all of them, but just giving you a simple example with the sign, you can see in how many scenarios one objects could be used. So when we use, for example, real aggregates, so sign could be a part of the whole assembly. Then if you use this spatial structure containing spatial structure, it means that these objects give me information that this is placed, for example, under IFC road part. Another classification, another relation called association classification gives me indication that this one is connected to certain classes, classification reference. Material, the same issue. I can have one object, but my object is connected to the specific material using this relation. And also note, material is not the property. Material is also entity connected to our objects with the specific association. Uh, Another example, you have the property sets. So also like a property set, they don't fly somewhere, but they are linked to our object using rel defines by properties. The same with quantity set. So this is the link between property set, quantity set with our object. And the last one, I think, very useful, it's IFC group. It's also connected. Our objects could be kind of placed in some basket, let's say imaginary basket as a group and a system. And this is the rel assigned to group. So you need to know that IFC object could be connected to different objects using different relations. And again, you can easily open your notepad if you want to know what relations you have. Just type IFC rel, the first six letters, and search all the result, and you see how many different relations you have in your file, because I just mentioned 8 of them. They don't know the specific number, but much more. So this is the spatial breakdown structure. Sorry, this was the this is we are going to talk about spatial breakdown structure, but we talked about before about the relations. So now let's see how relations, these certain relations, could help us to build the spatial breakdown structure. What is that? IFC has the something called when you open your model in any viewer, you always have this project tree. On the top, you have a project, you have an IFC site, and then you have a certain nodes. I call it nodes. Then you could have road, you can have a bridge, railway, marine facility, building. You could also use directly IFC facility. I will tell you this later. Uh, but also in addition, you have a IFC facility parts, and then you have IFC road part, bridge part, railway part, and marine part and facility part common. So this here you can call as more as a like of containers, like virtual containers that um, kind of group your objects in certain way and attach to some very nice structure project view, and how it looks in the reality. So if you have this, let's say, a very nice picture from ChatGPT, you can see here that I included all different mm, domains that could be described on the top level. So we have a road, second road, we have also facility, we have a bridge, we have a tunnel. Note here, tunnel is not yet released. It will come in IFC 4.4. I don't know about the status of this standard, but it's meant to be there. And also, as I said, if you don't find any specific domain that could fit to this, I have it on a picture, you can always rely on IFC facility. So this is what I, for example, done with Oslo municipality, or the water municipality. So they wanted to create water and sewer uh, handbook, or the manual for IFC. So we couldn't find a proper domain, let's say domain class directly. So in this sense, for this specific domain, IFC facility could be used. So every time, for example, because infrastructure usually consist of, let's say, 10 to 15, the huge projects, 10 to 15 domains, disciplines. So some of them, like road, bridge, you can easily describe. But what about the rest? And this is where you can use facility, because also, as you will see in the example in some minutes, you can define not the project structure not only for one file, but you can do it on a global way, like on a global level. And this is also what IFC 4.3 opens for you now. Before it was not that much used, but if you work with infrastructure, you know that you cannot describe everything with just one node. You have to, sometimes you call it, or very often, work breakdown structure. This is one way of dividing your project, but could be also classified by domain or by other function So this is also about how you structure the your project, and this is what I'm going to show you now. So imagine this is the IFC, this is the project, the huge project, and you can simply recognize the many different domains. But these domains in firstly could be divided in certain sites, some areas you want to work, or some, let's say, company or the stakeholder could take control over. For example, in coordination aspect. So this is, for example, one site. You can have a second site. This is just including all of them together. This is the third site, and this is the fourth site. So this is how you can basically divide your infrastructure models, and this is very common practice. But you can also do the same with another approach based on the alignment, because you see you have one alignment that's going through or going from A to B, and based on the kilometers, or based on the how to call it, yeah, miles, mile points, you can define your scope. So let's say, like, from this to that point, you have the IFC site one, then you have site two, and then you can have site three. So this is how you can structure your infrastructure models, and this is how you can play with it. So then let's see what we have inside. We take an example. So we will take this first IFC site. So how we can divide even more our project. So we have a IFC site, and then in IFC site we have the main road, one road. We have a second road. We have the third road. We have the fourth road, and then we can have also road 5. And in addition, we have a bridge and we have a railway. So this is how you basically can describe your file, your model, if it consists all them together. So on top you have IFC project, then you have a site, and then you also have different domains. But let's see how we can divide even more. For example, our road 1. So your road 1, you can divide even more, because you can say that, hey, this is a road, but this part is a roundabout. Then we have a road segment. Then we have another roundabout and another road segment. So if you are very much into such a details, this is a possibility with IFC 4.3. And the roundabout in this context, or road segment, is this predefined type. So we still have one definitions, one class, and we have the predefined type, which gives us more sense. But let's see how even more we can divide our roundabout. So if you have a road, then you have a road segment. You have let's see, road segment, you have a roundabout and another road segment. So you can divide it like this. You can firstly use this usage type. As you remember, I told you, remember this term, because firstly you divide your road longitudinally, but in addition you also can divide it even more using the lateral approach. So how the cross section looks. And in cross section you have two hard shoulders on the left and right, and you have a carriageway. Then you have a roundabout. So this is even more complex, because you can go this direction. So first we see the longitudinal division, and then have a lateral division. Like we have a carriageway again. We have a 5 shoulders, because we have 1, 2, 3, 4, and also inside 5. And then also again we have a central island. So this is the thing you can do with IFC. And I know this looks complex, and maybe not that many companies use this approach, but sometimes maybe it's needed. But just wanted to show you that this is the things you can now think about, because this is not like very simple approach like in building and building stories where you have one building story, second building story, third building story. Here you have to think spatially. You have to look at your projects from the top or from different angles depending on the case, and this is how you can structure your model. But I will also come back you that nothing is, I think you have to go and kind of rely on as much as possible on the default, more generic approaches. Here is how you can divide your model. As I said, you have one project, you have IFC site having some models, IFC site second having some models, that one of them is even more detailed just to show you the concept, but also site 3 and site 4. But I know that it's okay, it's possible uh, just to put IFC road as the main node and include all these tangible objects having the geometry inside this specific container or the specific domain. So this is also okay, depending on how you work with it. You have to just be aware that there is a certain logic that need to be followed. And I wanted to refer to this specific slide because I am new some of the authoring software. I use daily, for example, NovaPoint Road, sorry, NovaPoint in general as a tool for the authoring, but also I'm aware how Bentley Open Roads and Civil 3D works and Sierra Soft. And also I know that on the market you can find different solutions. Maybe if you know different, type please in the chat. I'm really uh, passionate about comparing all of them together. But from my understanding and from what I have learned, there is no one way of defining the cross section that could be used across different solutions. So imagine about the exchanging data. So for example, one software is just creating your corridors based on the templates, another based on the section, another by the string lines, another on the object centric. So this is not one approach but to the modeling. It means also that there will be no one spatial breakdown structure that could fit to all of them. So this is also, if you're working with the standardization or any requirements, remember to not specify too complex your spatial breakdown structure, because this could be not possible to deliver by some software. So this is also what I have learned, and I'm a fan of keep it simple, maybe not stupid, but keep it simple, and most probably it will be covered by many vendors. If you just do too much complex, as I have shown you with this roundabout approach, maybe some tools will not cover that. Maybe some tools will not open it correctly. So if we are talking about the industry state and where we are, I think we are about to let's say, support the IFC 4.3 in almost all the tools, authoring tools, but you can have also different level of detail. So if we stick to this, let's say, generic, more general approach, then I think it's a very, very good decision. Yes, and I wanted to show you how I approach this thing when I was responsible for the implementation in NovaPoint and Quadri. So this is together we found out with my dear colleague Jan Erik that this could be a potentially working solution for Norwegian market, and also this is how we see or how we in NovaPoint could support that. Because what is the difference in our tool that you cannot find in others? Like we also, I say we, but I, when I worked there, so we supported corridor definitions, we presented Pavel, yes, Pavel, Provi is also solution, but I think they use the AutoCAD engine, and I was focusing about own standalone solutions. Sorry for this comment, but yeah, this is how I see Provi. But coming back to Nova Point, this is, for example, we also produce the surfaces that, in fact, they are like virtual top surfaces, maybe not giving you too much information or too much uh, maybe value, but they could be potentially used in a software in a certain scenario, like for example, texturing, like presentations. So this is where you find it. But for example, using Civil 3D for to have a top surfaces, you have to use another tool to triangulate it. So you have to do extra effort to make it. So you more use solids. But in this case, you have also we produce, or NovaPoint produce solids and also top surfaces, giving you the shape of it. And we said that we want to also keep it, so we also put it to different kind of containers and also extract it. So this is approach we wanted to have, and depending on the use case, it could be used. And when you export from Quadri, you have these definitions also as a default. And of course, you can play with it, knowing the certain rules, as I said, like if you have you know about this aggregates rules or containing structure, you can start playing and creating your own definitions for that. So for example, you see here is the road part that it's dividing a road part segment, uh, usage type longitudinal, and we decompose it into the carriageway lateral, also pavement, because pavement, how you want to connect your pavement. Should it be connected to the corridor or should it be connected to the longitudinal section? So there is many questions appear when you start modeling using different tools and trying to compare and trying to find some um, one unique solution or one common solution that could fit everyone. So there is no one solution for spatial breakdown structure. You have to remember that. But I have like core principles for you, just some basics you need to know, you need to understand. You can make a screenshot of it, but you don't have to, because I will send you also this presentation later. So alignment, it's also nice that we can connect it directly to IFC project. It was asked by different implementers or the software vendors that this could be potentially a very good solution, because if you exchange just alignment, then you don't need IFC site, building or road and etc. You can directly just link it to project. And this is, for example, in railway, when you have a lot of alignments, usually like you have a station, there is a 10, 12, whatever, like many alignments. Instead of attaching them to site, you can just put everything under IFC projects and then send. Then you have an IFC facility, road, railway, so they decompose into the same kind of the family of the object. So IFC facility decompose into IFC facility or IFC facility part. Not like you cannot make IFC facility into IFC road part, or you cannot have a IFC road into railway part. But you can also decompose it into IFC space. There is also some uh, use cases where you can use a space. Then IFC real aggregates, this is what you need to remember. This is where you link IFC project, site, building, or road. They use IFC real aggregates definition. And IFC rail contained in spatial structure is where, when you want to link the tangible objects, these objects, you open the viewer and click on it, you see the geometry, you see the shape. This is where you use these definitions, these relations to connect to your spatial entity. So this is the logic, the principles you have to know, and also be aware, because this is also a very nice approach sometimes, that property sets could be connected to these spatial elements. So you have a, let's say, project, lot of information, but you have some general information, some project information, or some technical or more discipline oriented information. So this general could be easily connected to a IFC road, for example, instead of having everything on the object level. So this is also, just have in mind that when you will structure your guidelines or procedures or anything related to standards, imagine that you can also divide it into several pieces. Then geometry. So we know the object, space, relations, attributes, p sets, all of it. Uh, do the geometry, and then we will take a very short break just for you, maybe 2-3 minutes, and then we will go back to the rest, because also I remember I got this feedback from before that I could like talk in 3 hours, but people sometimes need to also go to toilet, for example, or grab a water and drink. So after geometry, we can have a 2 minutes break. So geometry, and I wanted just to list the most common geometries that are used in infrastructure. And you will be surprised, but there is no surprise. BREP, this is this kind of the surfaces connected together. This is the most commonly used definitions. And of course, this is the heaviest. So if you see the file that has like 600 megabytes or 500 megabytes or any big model, this is probably this is most probably because you have a BREP definition. If you want to have much less the size of the file, you should use something uh, called explicit geometries, and this is like swept definitions that having the path and also parameters. So you have a cross section and also some cross section following the path, and this is it also could be used when it's suitable. Of course, in infrastructure, you have all these irregular shapes, like imagine about the terrain or the volumes between the terrain and corridor. It's not possible to describe with any geometry, as you see. So BREP has to be used. But for example, for manholes, pipes, all these cables, reinforcement, this is where you can use this explicit if the software allows you, because this is not also easy to find the software that really support that. And there is also new definition. It's called section solid horizontal, but I think not that many software support that. And the difference between swept solid is swept disk solid, for example, as a pipe. So if you have a cross section, if you look at me now, so and you have a path, this is the swept, it's always perpendicular to the alignment. And when you have a section solid horizontal, so you have this cross section always indicating Z value on the top and just following a path the same, but not perpendicularly, but perpendicularly to Z uh, Z axis. So this is the difference. And as someone said in the chat, civil site design support that. I don't know the software, but good that we have someone. But okay, we can again we can export it, but who will receive it? This is also issue sometimes. So you know, better is maybe to this simpler, but everyone will understand your logic or the because you can have extraordinary definitions, but who will open it? So this is where we also need to anyway place somewhere in between, that we export this correctly, but we don't want to we don't sometimes we are not sure if everyone will receive it correctly. So also, yeah, this is what I wanted to show. So, and also in IFC, some certain definitions, geometry, are directly linked to use case we are going to do with our IFCs, because some of them, as you know, like for example, visualization or clash control or reference model or coordination, do we really need the very advanced definitions, or it's okay with what we have? For visualization, I think the brep is enough, like the this closed shell together. Clash control, the same, it's all about the geometry against geometry. Reference model, same issue. So we just need to see how the design looks. Coordination, when we look at the all disciplines together and try to find some some things that not working, I think it's also enough. Airforks design, maybe here, maybe not, but maybe not. Airforks design, I think it could be very complicated to use the explicit geometries. Here you have to also rely on BREPs. Quantity takeoffs, maybe when you just consider the corridor, then maybe we need the more advanced geometry. But we are also on this level that maybe it's not that relevant anyway. So I think that this is you need to also know what your tool can and also how the exchange scenario could look like. So who is going to receive it and how they're going to read it. So I need, let's say, I give you 5 minutes, or no, 3 minutes break, very short break, and then we will come back to the. I will just continue. So please, 3 minutes, and I will just change this to. We are back in 1723 or 5. Maybe you will understand it better. Yes. So see you soon. Okay, I am back. So I will give you again 1 minute before everyone will join, but let's continue. Let's focus on the software part. So I would like to now tell you a bit more about the software and also how you can test if the software has the proper level of implementation of IFC 4.3. So let's jump to what you really need to understand and what questions you can have in terms of the your um, IFC or software authoring software supporting that. So this is I just created for you the simple list of questions that you could have, and you can ask internally or externally, or if you want to talk to the vendor if they support that. And this is the basics I think that should be supported in terms of authoring software. So first of all, you need to know if the coordinate reference system works. You can fully support it. You can include the definitions about that. It's about if you export to IFC addendum 2, because this is not also obvious. Sometimes you just export IFC 4x3 without this postfix, and this is where you can sometimes not allow to open in other software, because for example I know that in Quadri there is a restriction. We don't read the IFC 4.3 without this postfix. Uh, then again, is it possible to export alignment? Alignment should be as well supported. And as I said, this was the first thing we have implemented, alignment, and it also changed a bit during the years, but alignment has to be supported. Then, and I know tested yesterday, one of the mentioned software as well, they don't do this even today. So, and we are around 2 years after certification, so I see that this is not the easy part still. Do we support explicit geometry? And as I said, BREP is the implicit, so this is based on the shapes connected together, irregular shapes. But for example, pipes, manholes could be exported using this swept definitions. And just ask if it's possible. Then, can you override the global IDs? This is sometimes you need to do it. Sometimes it's needed in the projects because you need to kind of change it. So it's if it's possible, if you can keep it, or can you overwrite? Can you also create a spatial breakdown structure as you wish? As I said, there is a plenty possibilities, but some software are limited and they just support one way of structuring data. But knowing the logic, you can create what you wish basically. So this is also a question to your vendor. Do you really support that? Can you allow me to create one site which is decomposed into 5 sites, and in every site I have 10 roads? Is it possible? Then do you support all the attributes? Because sometimes you are exposed you exposing just the few attributes and the rest it's not supported. And I also encountered this several times, that I was, for example, thinking that I did something wrong, but for example, the viewer I used didn't support this attribute and gave me the wrong value. But in validation service by Building Smart, everything was correct, but the viewer didn't support that. Can you export the custom properties? Because of course, BSI properties should be every single software should do that, but maybe not. But also the custom properties, do you support it? Can I define any property I wish, and also define any data type? Because you will see that you can do it in many ways. David, answering your question from the chat, can Quadri override GUIDs during export? Yes, it can. Then properties. Can I assign properties to spatial entities? Is it possible that I attach one set of property sets to IFC road, another to IFC railway, another to IFC site, and also another to IFC course? Is it possible or not? Because sometimes viewer can support it, very nice, but authoring software, I don't know. Then can I assign a geometry to spatial entities? And this is also this was, I think, the most difficult topic, because sometimes, for example, in certain use cases, you can have some box or some the how to call it, the space, the virtual space for some certain yeah, maybe for the very early stage when you need to coordinate, but you don't yet know about the level of detail of your objects, but you need to save the space for this object. So this is use case where you can use this the geometry on the spatial elements. Can you export the material also? Sometimes people say that material is only in the properties, but if you have it as an entity connected, then you also get much more of it, because you can also put a texture on it. You can have a specific extra property set just on a material, a lot of this. And also BSDD. Do you support integration with BSDD? BSDD is a classification using the classification reference mechanism, and also allows you to not only stick to the IFC classification word, but also link you to some external resources, some libraries, some classifications, etc., where you can find much more, or you can get more understanding of your objects. So you could be one object, let's say, connected through BSD to several classes. So you can work in different markets, and then have this could be used in yeah, kind of understood in different ways. IFC viewers, free viewers that supporting IFC 4.3, and I like them. I use them. USB browser, uh, very nice, very good choice. Uh, Italian software, very nice, very good. Like it. Thumbs up. Then Open IFC Viewer, very good as well, supporting a lot of stuff. My favorite, RDF in two versions. RDF could be on the desktop when you want to just something handy, just opening your object, your model. Then you have RDF on the desktop with more insight. This is what I use if I want to go into the details, find the relations between objects, see how different semantics, this is a fancy word I like to use, how different information are attached to it. So RDF really recommend. Beam Vision, it's obvious choice. Everyone use that. I have seen it in several countries, several people, like different people. This is Polish, that's why also I'm supporting that. Um, Also, sometimes just working with this beam vision could be dangerous, so you have to be aware, because you need to make sure that you know what you have in your file, because I will not say in the details, but sometimes could be challenging just relying on the information shown in beam vision. And lately, yesterday, I just found this KTM. I mentioned also in terms of this georeferencing. Nice software, but I had some challenges with alignment. I need to test it again. Maybe I did something wrong, but this is very nice option. And I know also from the from the previous times when they called FZK, because probably they rebranded. They probably also support textures. So if you know how to attach textures to your IFCs, this tool could be very nice solution. I didn't test myself because I don't know yet where can I do this, the texturing. Probably Blender Beam, if you know Bonsai, called Bonsai. Maybe you can do it there. Maybe you can also write in the chat which other software can author or attach texture to your objects. So I will really look into that. So this and probably the next, yeah. So this is the viewers. But also what I can recommend you after, as I said, I worked quite long time in Trimble, and I worked there like 5 years, last 5 years, doing the implementation in IFC 4.3, and one of them is Trimble Connect Object Manager, and I use it, and you can do it for free, I think for 30 days. But also what is nice, and I found it recently, that you can buy the license just for 1 month, the Trimble Connect Object Manager. And this for me was quite surprised because I thought before that you always need to buy the annual license. And in this case, as you see, you can let's say you have 1 month free and then you have a 40 euro per month. So this is nice. And I know that you can all from the list I mentioned, you can do there. So it was kind of thing I was doing. So if you want to tips where you can try your files, data, you can check this software. Really recommend. And this is basically the end of the first part. So if you can just write now what topic else you would like to elaborate. And then I can just tell you about the last part, and then we can take the questions at the end. So feel free to just discover or just show us what other topics are the most, or what really you would like to understand. What I didn't clearly explain to you. I know that IFC is very complex. I have learned this almost 7 years myself from the scratch, knowing nothing, just as a blind. Uh, yes, attributes and pset definitions once again. Integration of JSON mapping file with IFC 4.3. The topic, this one, JSON. I think JSON will be a lot of. It will be used a lot in next generation of IFC. Uh, then for people typing, let's wait what they will ask, what they will say. I know that how can I on the chat? I'm also reading from the chat. Uh, how can we configure Civil 3D for IFC 4.4 export? So even asking for the next version of IFC. Subdivision to road segments. Have you worked with Mensura Genius? Can you edit the spatial breakdown? I don't know Mensua. I don't know this software. Sorry. Checking models and finding the templates to check the IFC against the IDS. How to set up the templates for checking. Multiple alignments on a project level. How is it realized? Coordinate reference system in IFC. 7 parameters transformation. Standardization of attribute use. Please explain IFC rel once again. So as you see, there is a lot of questions still, and I know that the 1.5 hour, it's not enough to go deeper into every aspect. I can assure you that each of these aspects could be elaborate even more in more details, because I know that the topic has also interesting elements around. Can IFC 4.3 replace DMI, DMR for road, and why, how? And this was probably questioned by someone using NovaPoint because DMI, DMR is a native standard in Norway for the native data, corridor data. But in my understanding, you need to, I just answer this one. For IFC 4.3, you are not yet on the level when you can support scenario called design to design. You can reference your model, but design to design also needs to be, you need to have these parameters, the logic of the geometries inside. And the DMI, DMR, or maybe you can maybe not replace, but work in addition to that, because you have a string lines, you have a surfaces, you have a solids, you have a points alignment. Probably it's a potential there. Adding correct CRS and be able to check and validate. How can I create different MVDs to deliver? Uh, yes, so there is a lot of things that uh, we should uh, kind of focus on. But okay, so thank you for this thoughts. You can still write it in the chat, but I would like to move in, and I think this will disappear if I just come to the next one. So what I want to show you now, I want to show you what I have been working for some while, and I want to introduce you to some very nice project I am about to. So maybe you are know or not don't know something called Model Maturity Index. So this is kind of equivalent to LOD, level of development or level of detail. So where you go from the not that many details into very detailed model, saying this directly. So this is what I also wanted to do for the industry, and where I want to make you sure that you can also learn something more than just IFC 4.3. So I want to introduce you to something called IFC Infrastructure Masterclass, where I define these 6 steps where you can easily go through and learn BIM for infrastructure, starting from introduction to civil, then going to the specific use cases or the specific information that should be attached to your model, then specific use cases, then IFC fundamentals in details, but also just trying to understand all of it, and then about the core concepts of it. So I think this is what I want to show you now. So the program I'm going to release has 6 steps. The first one is just understanding the all behind BIM infrastructure. So we have several different standards. We have several different requirements. We have also different project phases, different contracts. So in the first kind of part, I would like to show you how you can work across different standards and how they create a background for GIS data or the infrastructure data. So this is the first part of this program. Then another is, well, you need to understand to work in infrastructure, in BIM in infrastructure, what models do we have and what information you could include to this model. So this is not only about the nice 3D models that you use in, let's say, in coordination, but also you can have a certain information attached to the certain objects. And you have also different models used in different circumstances. So this is the second part, is just to understand how you can produce the better models with having the good information inside. The next one is about the model use cases, as I said, and also refer to this several times, because you can have a model but you can also send it to many different places if you do it correctly. And there is certain scenarios where you can use your model. So you can, as I said, use, for example, for just for a visualization. What do you need for that? You can have a quantity takeoff. What do you need there? You can have a 4D modeling. What I need there? As I design to design reference model, do we need a logic? Do we need a spatial breakdown? Do we need a material? Do we need alignment? All these questions, I'm still getting these questions a lot. How can I structure more model that could fit in every single scenario? How can I define my model to be used on the construction site, or for example for the drawing generation? So in the third part, I would like to also answer these questions: what we can do better in terms of the defining the models. So if we have then the whole understanding on how BIM works in infrastructure, what models, what information, what levels, or where we can use it, then it's IFC 4.3. And IFC 4.3, today I just show you sneak peek of it, just a little piece, but I hope you anyway you learn a lot. But as you have seen, there was a much more questions. So this is the session where I would like to go in a deeper, um, go deeper and see how we can address these challenges, how we can understand IFC 4.3 even better. So all the relations that are needed, the spatial breakdown structure, different viewers, how they open our files, how different objects could be mapped with the native data. So all of this data, how you can define your IFC 4.3. Another one is going to the higher level. So all property sets, data type definitions, the coordinate reference system, geolocation, different material types, presentation layers, or also grouping and classification, or even different definitions of geometries. So all of this, I think this should be also covered to understand the full logic of IFC 4.3. And in the last part, so if you have it, then you can easily also think about the implementation. So how you can structure your data, how you can structure your models, how you can attach information to be used in several places. So for this particular chapter, for this particular element or the program, I will use, or I will rely on Trimble Connect Object Manager, and everyone will kind of get the license, free license for the 30 days, and everyone can learn and then decide if it's nice to have or not. So this is basically how I see the masterclass I created. And as you know, uh, I'm working, I was doing Beam Kernel almost for 6 years, so I also just gather, I think, around the 50 articles. You can, of course, anytime go to Beam Corner and read them. But I wanted something more, just to connect everything together in a certain and create a certain steps to deliver at the end the high quality BIM model. And also I hope to educate the industry and also make everyone uh, or put everyone on the same page. And I hope that this course will, or I don't want to call it course because it will be a more workshop interaction with you. And this is what I want to launch today. And you have still possibility to participate. And of course, this is just my idea about how I can help the industry to succeed. And as I said, I have some nice experience from every side, so I wanted to just bring it everything together and put it together and create this clear program for everyone. So if you are interested, I just recommend to participate. And as I said, for example, if you are very interested just in the theory, so you can just go for the practical knowledge when you will get just understanding of all these pillars I mentioned. But if you also want to learn about the software, then you can also take just this lesson when I always will always only focus on IFC 4.3, import, export, attaching classification, spatial breakdown structure, materials, presentation layer, colors, everything. And if you want both, you can also purchase it just as a bundled. And this is what I'm going to do. And I'm starting the first session 17th of March. So I really recommend you to participate. So of course you can find more information on this website. So please, I don't want to also make the aggressive selling pitch. I'm not good at that. You know that maybe some of you already know that I'm passionate about the topic.